You're 22. Your laptop has been running for 6 hours. 1 Python notebook, 3 stack traces, 7 browser tabs, a Kaggle medal, a GitHub portfolio, 400 job applications. Most disappear without a reply. The few interviews you get end the same way. We're looking for someone with more experience. Fast forward 15 years. Now you're in a boardroom. A model you built will decide which customers get approved for loans, which ads billions of people see, which warehouses stay open, and where a Fortune 500 company invests its next $100 million. Your compensation isn't just a salary anymore. It's stock, bonuses, equity, the kind of wealth that compounds while you sleep. Same profession, different universe, because data science isn't a coding career. It's an economic ladder where every level has its own math, and most people never make it past the first one. You think the formula is simple. Learn Python, master SQL, build machine learning projects, get hired. The math looks clean, until reality adds new variables. You need a degree, then a portfolio, then internships, cloud credits, a laptop powerful enough to train models, Leak Code Premium, GitHub, Kaggle, interview prep, thousands of dollars before your first paycheck. Then comes the biggest trap. Every entry-level posting asks for 2, sometimes 3 years of experience. So you build another project, another dashboard, another ETL pipeline, another XGBoost model. According to labor data, demand for data scientists remains strong, but so does competition. Thousands of graduates enter the market every year, turning junior hiring into one of the tightest bottlenecks in tech. The work isn't getting a job. The work is convincing someone you've already done it. You made it. The offer letter arrives. The title finally says, Data Scientist. You think the hard part is over? The math changes again. You expected neural networks, large language models, complex algorithms. Instead, someone hands you a spreadsheet with 1.8 million rows. Half the values are missing. The dates use 3 different formats. Customer IDs don't match. Nobody knows why. You spend your morning writing SQL. Your afternoon fixing ETL pipelines. Your evening explaining why yesterday's dashboard doesn't match today's dashboard. Nearly every model begins the same way. Clean the data. Validate the data. Clean it again. The code isn't the bottleneck. The business is. You learn new words. Feature engineering. Data leakage, cross-validation, model drift, not because they're interview questions, because getting any one of them wrong can cost the company millions. The salary is finally comfortable, but the hidden costs never disappear. Cloud compute isn't free. Courses become subscriptions. Every new framework promises to replace the last one. PyTorch, TensorFlow, MLOps, LLMs. If you stop learning for even a year, the industry keeps moving without you. Then comes the real boss, not Python, not statistics, stakeholders. An executive doesn't care if your ROC improved by 3%. They want one answer. Can we trust this model? You realize something uncomfortable. The people who get promoted aren't always the best programmers. They're the ones who can translate uncertainty into business decisions. Because in data science, building the model is only half the job. Getting people to believe it is the other half. You've survived the first bottleneck. People stop asking if you can code. Now they ask, can your model make money? The math changes again. It's no longer measured in accuracy. It's measured in impact. A 1% improvement in a recommendation engine can mean millions in additional revenue. A small mistake in a fraud model can cost even more. Your projects grow, so does the pressure. You're no longer working on a single notebook. You're managing data pipelines, feature stores, model versioning, A/B tests, and production deployments. Every prediction is logged. Every failure leaves a trail. Every decision can be audited. You hear new language every day. CI/CD, MLOps, inference latency, precision versus recall, SHAP values. The model isn't finished when it trains. It's finished when it survives the real world. Then reality fights back. Customers change, markets shift, behavior evolves. The model that scored 94% last quarter slowly starts making worse predictions. It's called model drift. No alarm goes off. Revenue simply begins to leak. So you retrain, monitor, validate, deploy, again and again. Your compensation grows. Maybe stock options, maybe bonuses. Maybe a 6-figure salary, but the hidden cost isn't financial anymore. It's mental. You're expected to learn every new breakthrough before it becomes yesterday's news. 1 month, it's transformers. The next, it's AI agents. Then a new open source model changes the benchmark overnight. You begin to understand the real game. Data science isn't about reaching the frontier. It's about chasing a frontier that never stops moving. And that's where most careers start to plateau. You've stopped proving you can build models. Now you have to prove they should exist. The math changes again. You write less code. You make more decisions. Your calendar fills with meetings. Product, engineering, finance, legal, compliance. The notebook stays closed. The whiteboard stays full. Junior scientists bring you their models. They've optimized the metrics, reduced the error, improved the F1 score. You ask one question: does this solve the business problem? Silence. This is where the career splits. One path leads to endless technical work. The other leads to influence. You become responsible for systems you didn't build, models serving millions of users, pipelines processing billions of records. A failed deployment isn't just a bug anymore. It can shut down a recommendation engine, trigger false fraud alerts, or cost the company millions before anyone notices. The jargon changes: SLA, data governance, feature store, model registry, root cause analysis. The biggest challenge isn't machine learning, it's alignment. Product wants speed, engineering wants stability, legal wants explainability, executives want results by next quarter. Everyone wants something different. You're expected to satisfy all of them. Your compensation keeps climbing. Base salary, performance bonus, RSUs that don't fully vest for years. The numbers look impressive, but they're designed to keep you where you are. Golden handcuffs. Leave too early, and you leave a large part of your compensation behind. This is the invisible wall of the profession. The people who reach senior level aren't necessarily the smartest. They're the ones who learn that in corporate AI, politics scales faster than algorithms. You're no longer judged by the models you build. You're judged by the systems you change. The math changes one last time. 1 hour of your work is expected to save thousands of hours for everyone else. You rarely open Jupyter anymore. Instead, you review architectures, challenge assumptions, decide which projects deserve millions in compute and which die before they're written. A single recommendation can redirect an entire engineering organization. The jargon changes again: technical debt, inference cost, scalability, data contracts, model governance, cost per prediction. Accuracy is no longer enough. A model that's 0.5% better but costs 10 times more to serve is a bad model. Now you're balancing mathematics against economics. The hidden cost isn't learning. It's responsibility. One rushed decision can waste months of engineering time. One overlooked bias can become tomorrow's headline. One security gap can expose millions of records. The pressure becomes quieter, but heavier. Your compensation reaches levels that once seemed impossible. A high base salary, large RSU grants, performance bonuses. On paper, your total compensation can exceed $500,000 a year, but most of that wealth isn't cash, it's equity. And equity only matters if the company keeps winning. Then comes the final boss: not technology, not competition, irrelevance. The tools that made you valuable 5 years ago are now built into software. AI writes code. AutoML builds baseline models. Copilots generate SQL in seconds. The work doesn't disappear. The leverage does. You survive by doing what automation can't: making difficult decisions, seeing patterns across entire organizations, turning uncertainty into strategy. Because at the highest level, you're no longer paid to predict the future. You're paid to decide what the company should do with it. You no longer build the product. You build the people who build the product. The math changes for the last time. Every decision is multiplied. Hire the right leader. 10 teams move faster. Hire the wrong one. You lose a year. Your calendar is no longer filled with model reviews. It's board meetings, budget forecasts, investor calls, regulatory discussions, acquisition pitches. The code base keeps growing. You barely touch it. Instead, you decide where tens of millions of dollars will be spent. Do you build your own foundation model or license one? Do you expand the data platform or hire another 50 engineers? Do you automate customer support or wait for the technology to mature? These aren't technical questions anymore. They're economic bets. Every answer has a price. Your compensation looks unreal: a large base salary, annual bonuses, performance shares, stock options that can become life-changing if the company succeeds. For founders, the upside is even larger. One successful exit can create generational wealth, but the hidden cost is uncertainty. AI changes faster than almost any industry before it. A breakthrough published on a Tuesday can make this year's roadmap obsolete by Friday. Governments introduce new regulations, competitors release better models, cloud costs rise, investors expect faster returns. There is no finish line, only another wave. And that's the part nobody tells you. From the outside, this career looks like a straight climb, from Python tutorials to million-dollar equity. In reality, it's a survival game. Every level demands a different version of you. The student learns, the junior cleans data, the mid-level ships models, the senior earns trust, the principal shapes systems, the head of AI shapes companies. The ladder never gets easier, the stakes just get bigger. And the people who reached the top weren't always the smartest. They were the ones who kept adapting, long after everyone else stopped.